right, hello. So my name's Kushi. I lead research at Aethos. I'll tell you a little bit about what we do at Aethos in order to explain what policies are and how they're used, and then get into a little bit of how policies can be used in intent-based systems. So starting off with what Aethos is. We build these things called policies, which go by a ton of different names. They can be rules, they can be conditional expressions, or in intent-based systems, often called constraints. Policies have been around for a long time in various different forms, especially in traditional technology. So, for example, PayPal has anti-fraud policies where they track transactions and they report fraudulent transactions and block those transactions from interacting with PayPal. Airbnb also has policies where they set blacklists where if you go to an Airbnb and you don't follow the rules of that Airbnb, then you'll be added to a blacklist such that you can't use Airbnb again. Uber also has policies. Those are simple reputation-based policies where you rank your driver ranks you back as a rider. And that's just a rule-based system for how Uber operates. And lastly, Netflix also has policies where based on where you're located in the world, you see different sources. So policies aren't necessarily just in a regulation context. They're very broadly any rule-based system. And so with that, we think that there need to be more policies within crypto. And that's largely because in the name of openness and permissionlessness, I feel like sometimes we don't have as many rules on how systems can operate. And those rules are very, very crucial for making a system operate well. So what Aethos does is we build a policy layer so that application developers can create policies for how users can interact with their applications, making it so that you can run decentralized autonomous organizations, protocols, or even dApps more efficiently using this rule-making system. And so how Aethos works is you can set any kind of dynamic policies through our platform. So policies can be any set of constraints or rules. Those are completely on-chain. They can be updated at any time. And they're also owned by the person themselves. So if a protocol decides to deploy a policy, they own that policy. They can make it so that if they're fully decentralized, their community can own that policy. And that policy can be updated through governance mechanisms, through a DAO, or it can be owned by a certain set of people. It's entirely up to the application developers themselves. We have a three-sided network with applications, operators, and data providers that all work together in order to make these policies happen. And the way that works is through our network. So typically when a user interacts with an application interface that has Aethos integrated, what the application will do is they'll send a message to the Aethos operator network with the transaction details. Those transaction details will then be compared to the application's on-chain policy to determine whether or not the transaction adheres to the policy that the application has set. If it does, they issue a signature that signs the message of yes, it adheres, or no, it doesn't, and that's embedded in the transaction object itself. The transaction is then sent to the client's smart contract, and it's validated against our set of operators. So we make sure that the operators are valid and that the signatures do indeed approve the transaction. Once that happens, transactions execute as normal. And so that's how this typically works. Policies nowadays, in terms of what we typically support, is on the risk management side. So policies are any kind of generalized pre-transaction computation, but we specifically focus on risk management at the moment, where we do anti-money laundering checks, we do integrated identities, exploit prevention. Those are some of our focus areas, but we do eventually want to expand to include other types of policies, such as like geolocation, rate limiting for tokens, Sybil resistance, as well as like asset unlocks in gaming. There's a lot of different policies that you can create. So why do policies matter in intent-based systems? And the main reason is so that policies can increase user expressivity. So when you have any kind of intent-based system, users can express their intents however that application interface allows them to, but it also abstracts away a lot of the execution details. And so you can use policies in order to give users more expressivity over how these intents are created and executed without overburdening them with having to create these constraints themselves. So this is a very simple example of an intent. Let's say I want to deposit asset A into a yield-generating vault, and I want it to be secure. Now, secure is really broad, and the user could define it, the application could define it, anyone can define what security means. But through this front end, I simply say, I want to deposit into a yield-bearing vault that's secure. And maybe the application said that secure means that it's any application that hasn't been subject to an exploit in the last 6 months. So now when a solver goes to execute my intent, they can only deposit my assets into a set of protocols that has not been exploited within the last 6 months. And that can be checked when the when the intent execution is being validated. The solvers will be able to choose, like the solvers will be chosen based on whichever yield is the highest. So that's an example of how you could use policies in an intent system. But why does this really matter? The main reason is because when you get to a world where you have a lot of things abstracted away from the user, you reach a point where users don't have as much control over their transaction execution, which can be a little bit dangerous for them. So in a chain abstracted world or even in an intent execution world, users might still want to have some control over the security parameters under which their intents are executed. And so having policies is an easy and convenient way for users to have some control over their transaction without having to explicitly state every single constraint. And so getting into why policies are different from constraints, policies are essentially a set of constraints. And so why do we need policies instead of just having a series of constraints? Well, the main reason is for convenience and modularity. So policies essentially pack a set of constraints. Policies essentially pack a set of constraints into one specific set. And so that's really helpful because then you can define them by very simple terms like something that's secure or something that's decentralized or something that's compliant. Now, as we saw in the Pint workshop, this is not actually what a constraint looks like at all. This is just a very high level of like what types of policies could you create. And then constraints would consist of multiple conditional expressions as well as potentially some external data providers in order to ensure that you can check those conditional expressions. So for a policy around security, no exploits in the last 6 months may seem very simple, but now you need a data provider to figure out, okay, what protocols have not been exploited. You need some kind of like trust assumptions there. It's a lot of series of steps in order to get to that simple no exploits in the last 6 months. And so that's exactly what policies do. So they pack a bunch of constraints into something that's a little bit less complex, but really convenient for the user. And the reason why that's necessary is because if you over-constrain your intent, you run into the problem of that intent might not be executed because it's been overly constrained. But if you under-constrain your intent, then you might not actually have the security parameters that you intended. So building robust policies is actually a very challenging task to do, but it allows intents to be executed within security parameters that users actually want. So when we talk about policies in the context of intent-based systems, they're very useful because they can enable any secure execution within both intent-based systems and chain-abstracted systems. Any questions? Cool. Thank you, guys.